Hello friends, let us study about software metrics. So what is software testing metrics defined as? It is a measurement which helps to estimate your progress, which track your progress, that defines how much time we have, how much resource we have, how many people we have, the number of headcounts we have, the quality and the health of software testing efforts. So again the budget, the time, the test, all parameters are defined. So this metric, which is defined in a quantitative terms, in the degree to which system, a system component, or a process poses a given attribute. Suppose if I'm saying that is a reliability, reliable. So this is a measurement up to how much percent it is reliable. Reliable has another factor of fault tolerance. Once it is failed, how much time it will work even though it has failed. So these parameters they need to be tested. So there are components, process, and they have the attributes, subcategories of the attributes. Now, software testing metrics that improves the efficiency and effectiveness of the entire software testing process, software procedure. You begin from your software test plan to software test specification till your software life cycle, testing life cycle, where that bug report is closed, software testing exist criteria. All those features are to be listed. Software testing matrix or a software test measurement is the quantitative indication which has the capacity, dimension, amount, and size of the attribute. Now, as for example, now we are talking about the software metric. So it will come, they will define as the total number of defects found, total number of errors found. Now since we are talking about the fault, error, uncovered defect, so now we'll use the term defect. What happens is the total number of defects or total number of failures it has occurred and how much time it required for your testing. Now, there are types of the metrics. One is your process, one is your project metric, and third is your software measurement. So, let us see about the soft process metrics. Now, these process metrics are collected. They are defined across the project initially when the project begins till the end. So, this is a long time collection of your data. That means it is long period of time it will go because the project is your comparable to your project size, whether it is small or large, but it is a long period of time required. So your project matrix is enabled as a software manager. Then it has a assess the status of ongoing process. It's an ongoing process. Of course, the process, the project, I can say. Now, since we're talking about the process, inside the process, the project has the number of process. So this is an ongoing process. Then there's a track potential risk. What are the risks that are coming up for each and every phase? Now, when I'm doing the test plan, there is a risk associated with it. And what are those risks that either what I plan maybe goes beyond the deadline because the people, the skill, the human skill required, skill employment, the skill person required to my work is not coming, is absent, is ill. So for this, there is a bound to delay happen. Then uncover the problem area. When uncovered defects are being listed out, they are prioritized as severe, medium, and low. So those have a critical, they have to be solved first. Then you evaluate the project team ability. That project teams is able to handle it or not. Whether they have the convenience at that point to control the quality of software work for the product. So now we study about the process matrix. Now there's a triangle over there to your right side and you will see that the product is on the top, people is on the left, technology is on the right and the process is inside it. That means how they are reflected. Now we derive this set of metrics as the base of the outcome that can be derived from your process. Yeah, okay. Now what happens is the matrix is derived from your process that what number of processes required, how many skill sets, how many will come. Now we are not talking about what we have to do, what is the scope, what is the boundary, what are the limitations. No, we are not talking about this board. But now we are talking in terms of metrics. So metrics and measurement talks about how many, how much. Now outcomes which include the measures of error uncovered. Now before the release of the software, we have uncovered errors. So we cannot deliver a software with the defects, so we have to remove those defects and which are reported by the end user. We need to solve that. So work products delivered, human effort expanded, calendar time expanded, all your deadline is expanded. Now it is a natural that individual software engineer might be too sensitive to the use of metrics collected. Sometimes this metrics can give me it's too sensitive because I cannot handle or I cannot measure those outcomes even it is goes beyond the deadline. So this data should be private to the individual, it should not be leaked out to somewhere. Now again the process metrics. Some process metrics are private. Now some data which are be released are private to the software project team. They will not release to the outside source. So these are the numbers that we have mentioned and now these are the following defects we have found. No, they will not. They will that is limited to the project team. Now software project team. So that includes the defect reported as I said, because this defect reported at the time of delivery will, if this comes out then entire thing is busted, so it's everyone blame game starts, other reason issues start. So we are not, now we should not be concerned with those reasons. We are talking about the defect measurement, so that should be limited to software projecting only. Public metrics generally digest information, so we need to keep some of the data limited to itself. Then again, we have a project matrix, that is the first application of project matrix are most of the software project occur during the estimation. Then this matrix collected from the past projects which are used for the efforts and the time, because now the work is about the efforts and the time for the current software and they can use for the future work also. As the project process, measure of time expended are compared to the original estimate. Now, since the work begins, so it have a significance about the project metrics, and that intent of project metrics have certain aspects. First is to minimize and the development schedule by making adjustment necessary. Now, if suppose it's talking about the deadline, the timeline, we should see that we should not go beyond that. Increase the time, increase the skill person to it. We should make little adjustment without risking, without propagating the risk. So mitigate is means to remove the potential problem and the risk. And second metric is used to assess the product quality on an ongoing basis. Now, software measurement has a direct measurement of the process. For example, we have a cost and effort applied. Okay. So and product we have line of code. Now how do we measure those? With the help of the product. In the product that is the code. So code is measured using LOC. So there is a direct measurement. And indirect measurement is the functionality, reliability, quality, testability, maintainability. So these are two direct and direct measurements. Now project metrics to be consolidated to create the process metric which are that are public, made public to software organization. Now size oriented metrics can be derived by normally quality. Now there are size oriented metrics, function oriented metrics. So to develop this we have line of code. So this size oriented metrics developed using 1,000 line of code, case for 1,000 line of codes. That means for each project error per KLOC. Now defect per 1,000 line of code or pages of documentation. So these are measured during a process metric, project metric. Now function oriented metric as a measure of function delivered by the application, or it is on a function based point. So we have computational function point that is based as a software features that have the information domain and a complexity. Now we are here for test defect metrics. Now test defect metrics helps you to understand the defects that are found and can be used to improve your testing and product quality in future. Because today I discovered number of defects and later on I'll just think that this defect should not come up on the next product. Defects are classified by assigning the defects priority. So how they are classified, like low, medium, critical, severe. Accordingly, they have been like assigned ranks 0, 1, 2, 3, and so if they are at high risk, they have to resolve first. So priority of a defect provides a management perspective for the order of the defect fixes. Then, if there is a severity of the defect, then team should have that impact that it should solve first. The priority of defect can change dynamically assigned. Once it is assigned, it can change, but depends upon the how critical it is. Now, severity is absolute and does not change. So it reflects the state and the quality of the product. Now, defect density and the defect removal rate. Sorry. So there is a good quality product that can have a long time before becoming it's a absolute. The lifetime of the product depends on its quality over the different release it goes through. What happens is like once the software quality maintains when it is in use, but once it is obsolete, like once it starts diminishing, it it goes off, it goes out of the shelf. So when that software product goes through the releases, that means it goes through multiple versions, the size of product in terms of code increases. Okay, so for example, like your Windows XP, I don't know how many of you heard of Windows XP because Windows XP, like I have used lot of times, plenty of time. I found very friendly using the XP. Later, when the Vista, when Windows 7, all these Windows, when they came, XP slowly started obsoleting. And when still I was using the XP, people said, why are you using the XP? Why can't you change your Windows from other, like Windows 7, we have Windows 10. Why are you still using at XP? And there are no updates available for XP also. So that means the XP has itself has started obsoleting and its multiple version has been stopped. Now you use your smartphone, all of you have the apps, number of the apps, and now when there's a download available, you update your apps with the with the up to date features. Why you do that? It's because to maintain that app, you want to use that app. To retain that app, you use that updates. So that means the line of code retained to update that app is increased. So that's why the metric is also increased. That means your defect density is also increases. So the matrix that maps the defect in the product with the volume of code that produced for the product. So it is not appropriate just to compare the number of defects across the releases. So a software product has goes to releases and later the size increases. But once the metric correlates the source code and the defect is defect density. This metric maps the defects in the product with the volume of code, that means the number of the code it uses. There are several standard formula for calculating defect density, and this defect is most practical and easy metric to calculate. So defects per KLOC is the formula is given total defects found in the product divided by total executable lines of code in KLOC. So this is the formula to find the defects per KLOC. Then we have every 100 lines of executable statement is the product counted on KLOC. So defects found in this can be as used as release criteria as well as defect quality indicator with respect to codes and defects. Now here we are talking about defects found in the code. So defects found by testing team have to be fixed by developer team. This is the understood statement. Now defect removal rate is the percentage that is used for your purpose. Now the formula for calculating your defects is given here, that defects found by verification activity plus defects found in unit testing divided defects found by tested teams into 100. Now you have productivity metrics. Now productivity metrics combine several measurements and parameters with the effort spent on the product. That means the team is progressing, understanding the reason of both positive and negative variations also. Then you have estimating number of defects found, you have estimation of release date and quality and the cost involved in the release. So each and every factor when associated with the product to be released, these parameters are to be calculated. Now defects per 100 hours of testing. This is quite difficult. Now, if incoming defects are producing, now the defects if are increasing, if they are discovering or uncovering those defects, it may mean various things like testing was not effective. If there are 100 hours defects per hundreds of testing, that means the testing was not effective, the testing was not done properly, the methodology used for testing was wrong, and so on. The effort spent in testing keeps falling. So this metric defect per 100 hours of testing covers the third point. That means the quality of the product was improving, but normally it was not. And normalizes the number of defects found in the product. So defect per hours is again given by a formula that found in product for a period divided by total numbers of hours spent to get those defects into 100. Then test cases executed. So that was a defect discovered. Now we have a test case executed. Now the number of test cases executed by the test team for a particular duration, which depends on your productivity and your quality spent of the product. Now the team productivity has to be calculated so that it can be accurately tracked and the current releases can be used for the next release. I'll stop the release now. I'll use the current release for the future release, for the next release of the product. So test cases executed for 100. So in this way, we have completed the software measurement, and you can even try to find the defects in your small code.